Here in section 2, I want to introduce you to Maxwell relations. What are Maxwell relations? They are shortcuts that relate changes in temperature, pressure, volume, and entropy to each other. They are mathematically partial derivatives, and there are only 4 Maxwell relations, and they relate to the 4 thermodynamic potentials: internal energy, Helmholtz free energy, Gibbs free energy, and enthalpy. So how did Maxwell calculate his relations? It follows this general heuristic. Maxwell relations are applicable to state functions. If you remember correctly, we can represent state functions as a function for one another. For instance, pressure can be expressed as a function of internal energy and volume, in the same way how Z can be expressed in terms of X and Y. When we do a partial differential on Zxy, it will look something like this. Notice that the m and n terms are here. Following on, you have to do the second order partial differential. Notice here, this is your m term, and this is your n term. When doing your second order differential, you will notice that this works out to d squared z dy dx, and this also works out to d squared z dx dy. Notice that these two terms are equal, and hence the right-hand side of the differentials are equal. Therefore, any kind of state function represented this way can be applied in a partial differential manner. So using that heuristic, Maxwell came up with his 4 Maxwell relations. With these 4 Maxwell relations, he noticed that this is the state function. So I call this the state function. And this is its functional relationship. And this is its Maxwell relation. So internal energy expressed as a function of entropy and volume can be expressed in a functional relationship like this, and in a Maxwell relation like this. We can repeat the same for entropy, enthalpy and pressure, Helmholtz free energy, temperature and volume, and Gibbs free energy, temperature and pressure. And these really are shortcuts in order for us to calculate different kinds of state functions and thermodynamic variables. For instance, if we wanted to find out what the entropy of a system was, all we had to do was figure out the differential in volume, temperature, and pressure, and all we had to do was use the last Maxwell relation to figure out what the entropy was.